Good morning, ladies and gentlemen. Please let me start by thanking the organizers of Argentina Mining for the opportunity to present to you today our Altar Copper Project located here in the province of San Juan. Altar is a Miocene porphyry copper deposit owned 100% by Peregrine Metals Limited, and it's located 25 kilometers north of El Pachon and Los Pelambres. A preliminary resource estimation completed in 2008 and based on the first 64 drill holes at that time returned us a total of 495 million tons in all categories at an average grade of 0.53% copper, and included a higher grade resource of 106 million tons in all categories at an average grade of 0.75% copper. Since this resource estimate was completed in 2008, we've drilled an additional 76 holes, bringing the total to 140 holes. However, this resource is still open laterally in several directions and also to depth. Altar is located in the department of Calangasta, near the border with Chile, approximately 190 kilometers due west of the city of San Juan. Our immediate neighbors in San Juan province include our porphyry copper sisters, El Pachon, Los Azules, and Rincones de Araya. We currently have two access routes. Each is approximately 170 kilometers in length. One is from Calangasta via Despensita, which we share with Los Azules and with Rincones de Araya. The other is from Barrial, and you can see the trace there in black, via El Pachon. A brief summary of the exploration history of the project. To our knowledge, the first exploration recorded on the project was by CRA in 1995 and 1996. CRA, with the merger of CRA and Rio Tinto became the operator of the project and carried on exploration from 1999 to 2004. And Rio Tinto in 2003 drilled the 7 initial drill holes which marked the discovery of the Altar porphyry copper deposit. Peregrine Metals in 2005 signed an option agreement with Rio Tinto, and in the last 5 years has carried out a geophysical program of IP, completed approximately 53,000 meters of drilling in 133 holes, done preliminary metallurgical test work, baseline environmental studies, and completed in 2008 a preliminary resource estimation based only on the first 64 drill holes that were available at that time, about 29,000 meters of drilling. The geological framework of Altar is fairly simple. The country rocks to the porphyries are early Miocene, andesites, dacites, and rhyolites. The porphyries themselves are middle-late Miocene in age, or 10 to 12 million years. They comprise quartz diorites, granodiorites, and andesites. The Pachon Fault lies to the east of Altar, and the Pelambres Fault lies to the west. And these two regional scale north-south faults form a structural panel that confines or limits the distribution of Miocene host rocks in the region. And we believe that these faults are also primary controls on the emplacement of the mineralizing porphyries. Just a note on the tectonic framework, this 10 to 12 million year age of the porphyries coincides with the onset of shallowing beneath the central flat slab segment of the subduction zone, and with the arrival of the subducting San Fernandez Ridge to this region. This image shows the three-dimensional solid models for the lithological units that we've mapped at Altar within the area of the resource block model. Andesite, there's a solid andesite there, is in pink in color. It overlies rhyolites, which are everything that are transparent in this block. The volcanics are intruded by andesite porphyry, shown as this mustard color or yellow-brown, and all are intruded by quartz diorite porphyry, shown here in red. I should mention now that what we refer to in subsequent slides as the central zone was initially a focus of exploration that was centered on the quartz diorite porphyry you see on the left there of the figure. What you see identified as the east zone is centered on the porphyry that's shown in red there on the right-hand side. This is a photograph of core from the discovery hole drilled by Rio Tinto in 2003, and it shows typical quartz diorite porphyry crowded with white plagioclase phenocrysts and with a very intensely developed quartz veinlet stockwork. Moving on to the alteration, this is a panoramic view of the altar alteration system looking generally to the south at El Pachon and Los Palambres on the horizon. And at the current levels of erosion, the system is exposed at the transition between intense pervasive sericitic alteration, kind of at the levels where the text there says east zone and central zone, and the overlying advanced argillic lithocap, which occurs on the very highest ridges you see kind of in the background there and wrapping around, completely surrounding the porphyry copper system below. This is Iconos imagery from April of 2008, and it shows the alteration footprint, which measures about 4 kilometers in the east-west sense and about 2.5 kilometers in the north-south sense. The ridge tops show advanced argillic alteration related to telescoped high sulfidation epithermal gold-silver deposit or system, which lies directly above the sericitic alteration at the upper levels of the porphyry copper system. This slide summarizes the key alteration assemblages at Altar. The earliest potassic alteration is characterized by quartz, biotite, K-feldspar, magnetite, rutile, and hydrite, and is related to A and B veinlets. This is overprinted by sericitic alteration, comprised of quartz, sericite, illite, tourmaline, and hydrite, along with peripheral chlorite and specularite, and this is associated with D veinlets. The advanced argillic alteration on the highest ridges is made up of quartz, alunite, kaolinite, pyrophyllite, barite, native sulfur, and sulfur salts, and is associated with silica ledges and vuggy residual quartz at high levels. This next slide is a summary of the major hypogene copper mineralizing events at Altar, beginning at the earliest stage with a low sulfidation chalcopyrite barnate assemblage related to A and B veinlets in the potassic alteration zone preserved at depth in the deposit and generally only visible or observed in drill core. This is overprinted by a high sulfidation chalcocite barnate assemblage, which is related to intense D vein development and strong sericitic alteration and occurring at shallower levels. We have supergene digenite and covalite observed beneath the base of oxidation underneath the leached capping. And this supergene mineralization coalesces with the hypogene chalcocite in the upper portion of the deposit to form a combined hypogene supergene copper enrichment blanket. This is the first of 3 photomicrographs I'll show you, and this particular one shows hypogene chalcocite, which is gray, intergrown with chalcopyrite, which is yellow, at the expense of very early pyrite, which is white in the image. The second one shows again chalcopyrite, which is yellow, clearly being replaced by supergene digenite, this blue-gray color, and supergene covalite. Here on the final photomicrograph, we see pyrite again, overgrown by hypogene chalcocite, which is gray, the yellow chalcopyrite, which are in turn being replaced by supergene digenite and covalite. Okay, now for some drilling highlights. This slide shows a selection of 13 representative holes drilled between 2003 and 2008 that are part of the database used for the 2008 resource estimation. Shown in black in the little boxes are the overall intersections, and the intervals in red represent mineralization from the high-level chalcocite-covalite dominant mineralization. Highlights include our deepest hole, which you see kind of in the center of the image there, ALD 43, which returned 719 meters at an average grade of 0.72% copper. This included 82 meters at an average grade of nearly 1% copper from the high-level chalcocite-covalite dominant mineralization. And in blue there at the end you see this is from the very bottom of the hole, and this is chalcopyrite occurring in the deep potassic alteration zone in the very deepest part of the system. Another highlight was, for example, ALD 49, which returned the same average overall grade of 0.72% copper over 518 meters, and included at the top of the deposit 194 meters at an average grade of 0.93% copper. This next slide includes the 2010 drill holes along with the earlier holes, and they're plotted over top of the 2008 resource block model. The colors in the plan here represent copper values in the upper 15 meters of the resource block model, as depicted in the legend over to the right-hand side of the image. Again, the intersections in red in the little text boxes represent high-level chalcocite-covalite dominant mineralization. Highlights of the 2010 drilling include holes ALD 73 and ALD 76, which returned 86 meters at 1.14% copper, 112 meters at 1.54% copper, respectively, both in the high-level chalcocite-covalite dominant zone. ALD 83, there to the bottom, returned 191 meters at an average grade of 0.96% copper, again in the high-level chalcocite-covalite zone. And ALD 85 with two intersections of 86 meters at 0.84% copper and 56 meters at 1.2% copper, again both in the high-level chalcocite-covalite dominant mineralization. Now, the 2008 resource estimation we completed was based on the first 64 drill holes completed between 2003 and 2008, and representing about 29,000 meters of drilling. This preliminary estimation gave us a total of 495 million tons in all categories, averaging 0.53% copper, and that's at a 0.4% copper cutoff. This includes 209 million tons at an average grade of 0.65% copper in all categories, as well as including 106 million tons in all categories at an average grade of 0.75% copper, and these at higher cutoff grades. Please note that since this resource estimation was completed in 2008, we have drilled an additional 76 drill holes. The table on this slide summarizes the 2008 resource estimation over a range of cutoff grades from 0.2% copper up to 0.7% copper. Total contained metal on the right-hand side columns in all categories works out to 5.8 billion pounds of copper and about 1 million ounces of gold at the 0.4% copper cutoff, and 11.3 billion pounds of copper and 2.3 million ounces of gold at the 0.2% copper cutoff. The gold is recoverable from a copper concentrate and is expected to add roughly 5% to the potential revenue value. Now, this image is a shot of the 2008 resource model looking north and showing the 0.2% copper grade shell in green and the leach capping in red. Toronto's 500, these enhanced grades at the top of the deposit may represent an opportunity to recover a significant proportion of development costs during the early years of production. And in conclusion, the 2008 resource estimate based on the first 64 drill holes comprises 5.8 billion pounds of contained copper in all categories at a 0.4% copper cutoff. We expect that the addition of the 76 holes drilled in 2010 will significantly increase the size and the confidence level of the 2008 resource. The deposit, however, still remains open to expansion in some lateral directions and everywhere at depth. We are currently preparing an updated resource estimation and carrying out a preliminary economic assessment, which we expect to complete in the coming months. We have planned an extensive drilling program for the coming field season, which will include continuing resource definition along with a substantial metallurgical and geotechnical drilling program. Okay, on behalf of the exploration team at Altar and the management team of Peregrine Metals, I want to thank you again for the opportunity to present the Altar project to you here today. Thanks a lot.